We'll now discuss how we would translate an expression from infix notation to postfix notation. The approach that we would use is actually very similar to how we would evaluate the infix notation. There are just a couple of small changes to the approach. So instead of evaluating the expression, we'll just rearrange the operators and operands into the postfix notation format. We'll take care of evaluating the expression later. Once everything is in postfix notation, that's when we'll take care of evaluating the expression. So just as we evaluate infix notation expressions, we're still going to read from left to right, and each character that we read is going to be copied into some postfix output string. So now we're going to have a string that gives us the postfix notation. The trick is knowing when to copy different things. When do we copy the operands? When do we copy the operators? Well, if we read an operand, we're just going to immediately copy it to the postfix string. That's why we saw in a lot of our examples that all the operands were still in the same order, regardless of whether it was infix notation or postfix notation. The challenge, though, is whenever we copy an operator. That's going to be more complicated. And the rule of thumb is going to be whenever we're supposed to evaluate, that is when we're going to copy the operator to the string. Let's do an example. Let's say we want to translate a plus b minus c. So here we're going to keep track of what we've read. We're going to keep track of the infix notation that we've parsed so far. And then we're going to keep track of the output string, the postfix notation. We first read an A, so we've parsed that, and since it's an operand, we just immediately put that in our output string. We then read the plus sign, so we've parsed that. We don't include it in the postfix notation just yet. We're going to hold that off to the side, and then we'll add it later whenever we're supposed to evaluate the addition. We read the B, so that's an operand. We add it immediately to the postfix notation, but we can't put in the plus sign just yet because we need to know what comes next in order to determine about whether we can evaluate A plus B at this point or not. We see the next symbol is the minus sign. So that means that we can evaluate the addition part at this point. So instead of evaluating, we will copy the plus symbol and put it in our postfix notation. We next read the C, so that means that we would put that immediately in our postfix notation, and we would see that we're at the end. So that means that what we'll be able to do is we can copy the minus sign over to the end because, well, if there's nothing else, it means we would evaluate whatever the result of A plus B is and then subtract it by C. So we'll tack that on here, and we would see that our final postfix is AB plus C minus. Let's do another example where we're going to translate A plus B times C into postfix notation. We'll first read the A, nothing special here. We'll then read the plus sign, so we don't add that to the postfix just yet. We only have the A so far. We'll then read the B, so we'll write the B to our postfix string. Now remember, since even though we had A plus B, we can't evaluate just yet. We have to see what the next symbol is. And in this case, we read the multiplication symbol. And this means we cannot copy the plus sign just yet because we're going to have to do B times something before we can do A plus something. So we can't add the plus sign to our postfix notation just yet. We read the C. So we now read A plus B times C. We write the C to our postfix notation. So now that we have B times C, we can copy the multiplication symbol over. So this is what it would look like. So we tack on the multiplication symbol. So then, since now we have the multiplication part taken care of, we can copy the plus sign over. So now we would add the plus sign at the end. And this works because if we were to evaluate this, we would do B times C first, and then that result and add A to it. And that would give us our final result. So this is the correct postfix notation for A plus B times C. Let's do another example, and this time we're going to include parentheses in our expression. So we're going to translate A times B plus C, where the B plus C is in parentheses, and translate that into postfix notation. We first read the A, so we'll write that to our output string. We then read the multiplication symbol, so we've parsed it, but we don't write it just yet because we can't evaluate right away. We then read the left parentheses symbol. So once again, we can't do any evaluation just yet. So even the parentheses is not included in our postfix notation. We read the B, so we're going to put the B in our postfix notation, but we can't copy the multiplication symbol just yet because we still have that parentheses. So we have to handle that part first before we can handle the multiplication part. So we can't copy that symbol over right away. We then read the plus sign. We can't evaluate anything yet, so we don't copy the plus sign over just yet. We then read the C, so we'll copy that over. So right now our postfix notation is ABC. We can't copy the plus sign just yet because we need to know what the next symbol is. We see that it's a closed parentheses, which means we can now copy the plus sign because we can evaluate B plus C. So we'll add the plus sign to the end. And since B plus C is evaluated and there isn't anything afterwards, well, technically we didn't evaluate it yet, but we would, then we can copy the multiplication symbol over. So we can tack that on at the end of our postfix notation. So we see we get ABC plus and then times. So notice that if we cannot copy an operator just yet, we have to look for the next operator. So then the question is, well, what do we do with those operators? We just said so far, we just put it off to the side, but where do we store it? Well, we can use a stack to take care of that for us. So this lets us handle the operator order in the postfix notation. Let's do one more example. So here we're going to translate A plus B times the quantity of C minus D. So we're going to translate that into postfix notation. And we're also going to keep track of the stack of the operators so you can see how we can use a stack to help store these extra operators. We first read the A, so we write that to our postfix notation. We then read the plus sign. We can't evaluate anything yet. We can't write it to our postfix notation yet. So we're going to push the plus sign onto our stack. We read the B, so now we're going to put that in our postfix notation. We read the multiplication symbol, so we can't evaluate anything just yet, so we don't write it to our postfix string. So we're going to push that onto the stack instead. We then read the left parentheses. So we don't add that to our postfix notation either, but we put that into our stack. That way later on we can tell when we've evaluated everything in the parentheses before continuing on. So we'll add that onto the stack. We then read the C, so we're going to write that to our postfix notation. We then read the minus sign. We can't evaluate anything yet, so we'll push the minus sign onto the stack as well. We then read the D, so we're going to put that on our postfix string. And then we still have to see what comes next before we can evaluate anything. We then read the close or right parentheses. So this tells us that we can't evaluate C minus D. So what we do is we pop the minus sign from the stack, and then we write that onto our postfix notation. Since we're done with the part in parentheses, we can pop the parentheses symbol off the stack. We can now evaluate the multiplication portion of the expression. So we would pop the next item off the stack, which is our multiplication symbol, and we would write that to our output string. And then finally, we would evaluate the addition portion. So we would pop the stack again. We have our plus sign, so we'll write that to the end of our output string. So we would get A, B, C, D minus, times, and plus.